Hi everyone, Mr. N. We're now in Unit 7, applications, right? Applications related to linear equations. And as you can see in front of you, we have problem number 7. For this problem, this is from your manual, right? For this problem, you have to make a table of values and you have to graph the linear equation. Okay? Let's start with part A. Part A. Good. The total amount a cable customer pays for cable is shown by the linear equation C equals 75 plus 50M, right? Where M is the number of months subscribed. Determine the cost when M equals 6, 12, 18, and 24. Okay, so as we talked in class about it, you have to make a t-table. Okay, now it's going to be either an horizontal t or a vertical t-table. I like the vertical one. Okay, so what I said, oh, hold on. We're going to make a t-table, and now my bamboo tablet is not listening to me, but anyway, t, right? But let's make it double t. Okay, and you guys remember that. So on the first column, you will put your M, right? The number of months. In the middle here, you will have the equation that determines the cost that your customer has to pay, which is 75 plus 50M. 50 times the number of months. And obviously on the last column, you will have C, which is the cost. Okay? And because the problem is telling me what value of M I should use here, just plug them in. I will have the first one M equals 6, the second one M equals 12, the next one M equals 18, and 24. Okay? And we will move on. If M equals 6. Okay, what's happening here? Well, the cost will be equal to 75. Okay, that's the flat fee of his monthly subscription probably, to which you will add 50 times M, which in this case it's 6. I'm going to use parentheses just for you to see that I'm doing the substitution. Instead of M, I'm putting 6, right? Well, very quick order of operations is telling you that you have to multiply first, right? 50 times 6, that will be 300 plus 75 will be $375, right? Moving on, the next one. Okay, let's change color for, for the aesthetical point of view, to make it look prettier. The cost will be 75 plus 50 times M, which is 12 now, 12 months. Okay, now easy to find this because 50 times 6 was 300, and now here we have 50 times 12, that would be double, right? Double of 50 times 6, which is double of 300, would be 600 plus 75 gives you 675. Okay, next one. How about, the cost after 18 months? The cost will be given to us by 75 plus 50 times 18. Okay, now, and to be consistent here, I'm going to use the same parentheses for my substitution. Order of operations again, you multiply 50 times 18. The easiest way is to remember that 50 times 6 was 300. 50 times 18 is 3 times that, right? So it will be 900 plus 75 will give you 975. And the last entry for the number of months, 24, the cost will be given to you by 75, the flat fee, plus 50 times 24. Okay, What is an easy way to find this one? We know we have to multiply first. Order of operations requires multiplication before addition. I'm looking at 50 times 12, right? That was 600 we said. Well, 50 times 24 would be double that, which gives you 1200 plus 75. That will make 1275. And here we are, okay? We have completed part A of our problem. Part B now says graph, okay? And obviously you will have, you know, the coordinate system here. Okay, imagine that my lines are straight. If you're looking at your values, M is positive, C is positive, so I need only the positive side of the X and Y axis, right? Here is your Y, which you can say represents my cost. Here will be my X, which stands for the number of months, okay? The origin where everything is 0. Now, the number of months goes from 6 to 24. To have this fit in your graph, you're going to make 24 here, right? You're going to say this is 24 months, and from here, you know that half of it will be 12, half of 12 will be 6, halfway between 12 and 24 is going to be my 18. You see how nice I've been able to set the, you know, the unit on my x-axis. Now, the vertical one, as you notice here, goes from 375 to 1275, which is almost like you know, 4 times that, right? The only difference is the 75. And you should you know, try a similar approach. You may say this is 1275, right? Well, half of that will be or almost half of that, let's say, you know, if this is half, 675 is a bit higher than half, so this is your, oops, this is your 675 right there. We're going to use approximation, right? We cannot be perfect in this one, but you know, by doing it this way, you can show me exactly, right? Now 975 is what? Halfway between 675 and 1275, right? That's 975. How do I know that? From 675 to 1275 is what? 600 divided by 2, 300, 6 plus 309. And here will be, over there somewhere will be my 375. And I'm done. The next thing, you have to represent every coordinate pair, right? Because this is 6 and 375. Next one will be 12 and 675. Next one will be 18 and 975. And the next one will be 24 and 1275. Can you guys tell me where is my graph starting from? Basically, what is the y-intercept of this function? Everybody sees that? The y-intercept is what? 75. Okay, so I know that my line does not, I mean, intersects my y-axis again. Hold on. At the point with the coordinates. Unbelievable. All right, looks like my my software doesn't want to, for some reason, reads that as you know, I'm trying to copy that 75, and that's where your graph will start from. In order to graph, first of all, you plot your points. Let's use another color for it. So for 375, that will be the cost after 6 months. 675 will be the cost right after 12 months. 975 will be the cost this customer pays after 18 months, and you know the other one, but you know what, because I already have 3 points, I can, well, more than 3, 4 points, hold on, it has to be straight. You guys see that, right? It has to be straight and it should connect my point. I imagine this is a straight line, but you got the idea, right? Obviously, because we're approximating here, the graph is not perfect, but this is what should be done in order for you to get you know, a full score on this problem.